Hi students, this is the fifth session of Elasticity chapter. In this session, we are going to discuss the theory of cantilever. After the completion of this session, you will be able to know what is meant by cantilever, expression for depression at the loaded end, expression for depression at the loaded end when the cross section of the beam is circular, expression for depression at the loaded end when the cross section of the beam is rectangular. A single cantilever is a horizontal beam fixed at one end and loaded at the other end. If we loaded at the other end, then the depression of the loaded end takes place. Then now we will discuss the expression for the depression at the loaded end. Here EF is the neutral axis of the beam and at end E the beam is fixed, at the end F is at the end F the load is applied. W is the load applied. Due to that load, then the point F comes to the position F dash. Here we consider a point P which is at a distance x from the fixed end E. Then another point Q which is at a distance dx from the point P. Then the length dx suspend an angle d theta at point O, where O is the center of curvature and R is the radius of curvature of the beam at point P. Then F dash is very close to F and hence EF is perpendicular to FF dash. Then PC is the tangent drawn on the line FF dash from the point P and D is the another tangent from the point Q on FF dash. If POQ is d theta, then the angle CPD is also d theta. Then CD is a depression of the loaded end due to the portion of the beam PQ. Then the total depression is given by FF dash. Then moment of the couple due to the load W is equal to W into PF dash and it is equal to W into L minus X because P is at a distance of L minus X from the point F dash. Then at equilibrium, the bending couple is equal to restoring couple, and in the last session we know that bending couple is equal to QIG by R. Then the restoring couple is equal to W into L minus X. Therefore, at equilibrium, W into L minus X is equal to QIG by R. Here R is the radius of curvature of the neutral axis at point P, Q is the Young's modulus and Ig is the geometrical moment of inertia. Hence, 1 by R is equal to W into L minus X divided by Q into Ig. As we move towards the fixed end, the moment of the load increases because the distance L minus X decreases and hence radius of curvature will be different at the different points. Consider another point Q close to P at a distance dx. The radius of curvature at Q is R because of small distance dx. Therefore, PQ is equal to r d theta and it is equal to dx. R d theta is equal to dx by r. Then we know that 1 by r is equal to w into L minus x divided by q into Ig and dx as it is. Then draw tangents at points P and Q meeting the vertical line EF at point C and D respectively. Then the depression of the point Q below P is equal to CD and it is equal to dy as we already know. It is equal to L minus x into d theta. Therefore, dy is equal to L minus x into d theta value is w into L minus x dx by qig. Therefore, dy is equal to w by qig into L minus x whole square into dx. The total depression is given by ff dash, it is equal to y. Therefore, y is equal to integral of w by q into ig into L minus x whole square dx between the limits 0 to L, that is 0 to L. Then y is equal to w by q into ig 0 to L square plus x square minus 2lx, that is the expansion of L minus x whole square to dx. Then y is equal to w by qig, then L square dx integration is L square x, the integration of x square dx is s cube by 3, the integration of x is x square by 2 and 2L is the constant. Then from the limits 0 to L, then we have y is equal to w by q into ig L cube plus L cube by 3 minus L cube. Therefore, finally we have y is equal to w L cube by 3 qig. And this is the depression of the free end of the cantilever. Then let us discuss about the special cases for rectangular cross section and circular cross sections. For rectangular cross section, we have Ig is equal to AK square, where A is the area of the rectangular cross section and K square is square of the radius of gyration. And A is equal to BD and K square is equal to D square by 12 for this rectangular cross section. Therefore, Ig is equal to BDQ by 12 and Y is equal to 4WLQ by QBDQ. And here W is given by the mass attached to the free end into exertion due to gravity. W is equal to M into G. Then for circular cross section, Ig is equal to AK square is equal to pi r square into r to the r square by 4. Therefore, Ig is equal to pi r to the power of 4 by 4. And finally, y is equal to 4WLQ by 3Q pi r to the power of 4. Then questions of this session. What is cantilever? Derive the expression for depression at loaded end of the cantilever. Then the reference books are Properties of Matter by D.S. Mathur and by R. Murugesan and by Brislal and Subramaniam. College Physics Volume 1 by Sundararajan. Thank you.